Teacher Mamu. Today I will teach you about tests for similarity of triangles. Okay? Tests for similarity of triangles. Okay. Before I proceed to the present lesson, I want to remind you some of the points that we have seen in the previous lesson. Okay, in our previous lesson, we have seen a certain definition regarding similarity of two triangles. Okay, do you remember the conditions to say two triangles are similar? Well, if you say one of the conditions for similarity is all pairs of the corresponding angles are congruent, and the second condition for similarity is all pairs of the corresponding sides. Okay, the ratio of all pairs of the corresponding sides are proportional. Okay, these are the two criteria that we were using in the previous lesson. So based on that definition, we could see different examples, right? So in our present lesson, we will see a short and precise way of checking similarity of triangles. Okay, so we will see three different tests for similarity. Okay, the first one is angle-angle similarity theorem. Okay, angle-angle similarity theorem is one of the theorem that we use to check whether two triangles are similar or not. The second one is side-angle side similarity theorem, and the third one is side-side-side. Okay, these three theorems are very short and precise, and it helps us to easily identify whether two triangles are similar or not. So we will see each of these theorems separately. So let us start from the first theorem. Okay, the first theorem under this topic is theorem 4.1, which is about angle-angle similarity theorem. Angle-angle similarity theorem. Okay, so when we come to the first theorem, this theorem tells us if two angles of one triangle is congruent to another two angles of a certain triangle, then the two triangles are congruent. Okay, I repeat it. If two angles of a triangle, if two angles of a triangle is congruent to the corresponding two angles of another triangle, then the two triangles are similar. Okay, so this first theorem, or angle-angle similarity theorem, requires two congruent corresponding angles. By default, if two of the corresponding angles are congruent, the third angle will also be congruent. But we don't care about the third angle. So geometrically, if we have two triangles, say triangle ABC, and triangle DEF. Look at these two triangles. So if we think that triangle ABC is similar to triangle DEF, okay, if these two triangles are similar, this theorem 4.1 tells us two of the angles, say angle A and angle D, must be the same angle B and angle E must be the same. Okay, so we need to have two congruent angles to say the two triangles are similar, right? So if these two triangles are similar, you can directly apply the concept of proportionality, okay? The ratio of the corresponding sides must be congruent. So this implies AB over DE must be the same as BC over EF. It's exactly the way we did before. BC over EF. And the last ratio is AC by DE. AC by DE. Okay? So this proportionality can be obtained from these two corresponding congruent angles, right? So shortly, this can be expressed as angle A and angle D are congruent, and angle B and angle E are congruent. Okay, the only thing that we can take is these two congruent angles. The main thing that you can take from this theorem is if you have these situations, if you have two corresponding congruent angles, okay, you need to write this way, then you can generalize that the two triangles are similar. Let me give you a very simple example of this kind. For example, consider the triangles below. Say one of the triangle is a triangle having angle 35, 70, and the other triangle is a triangle having angles 70 and 75. Okay, consider these two triangles. Based on theorem 4.1, can we really say that these two triangles are congruent? Well, at the beginning, it seems these two triangles are not similar. I'm not saying about congruency, it's about similarity, make a correction in that way. If you are asked to check whether these two triangles are similar using the first theorem, what will be your answer? At the beginning, it seems we don't have two corresponding angles which are congruent, so we cannot say these two are similar. You may say like that, but you need to check all the angles and compare whether we have two corresponding congruent angles or not. So you all know that the sum of the angles of the interior angles of a triangle is 180 degrees, right? Before you directly compare these two triangles, you need to check the third angles and try to find two congruent angles. So we can do that thing if we know their third angles. Okay, now here we need to apply the concept of the sum of the interior angles of a triangle is 180 degrees, right? We will prove this thing in the next unit. For the time being, let us keep this thing in our mind so that let us know their third angle. Now, this is 70, this is 35. We don't know the third angle, say that is x, but the sum of all these three angles must give us 180 degrees, right? So you can say that x plus 70 degrees plus 35 degrees is 180 degrees. Then the sum of these two is 105. So x plus 105 is 180 degrees. Now we can get that x is equals to 180 degrees minus 105 degrees. This implies x is 75 degrees, right? Okay. Now here this degree is this is 75 degree, right? Similarly, we need to determine the third unknown angles in the second triangle. Say that angle is y. Say this is y, okay? So how do you get the value of y here? Well, if you are saying that the concept of the sum of all the interior angles of a triangle is 180 degree, so let's calculate it. Y plus 70 degree plus 75 degree is 180 degree, right? So the sum of these two is 145. So 145 is the same as 180 degree. Now the y value becomes y is equal to 180 degree minus 145, which is 35 degree. Okay, here the third angle in the second triangle is 35 degree. Now let's go back to the triangles. Here we are considering these two triangles, and we are trying to determine whether these two triangles are similar or not. Okay, here as we can see, there are two congruent angles. These congruent angles are 35. Here we have 35. The other one is 70. Here 70. Okay, don't worry about the third. By default, the third angle will be the same, right? So consider the first theorem that we have seen. Theorem 4.1, it was about angle-angle similarity. So if you have two corresponding congruent angles, then the two triangles are similar. So clearly, we have two corresponding angles which are congruent. So we can say that these two triangles are similar, right? So this is a very simple case of theorem 4.1. So let's see a certain formal proving. Given that BC is parallel to DE as shown in the figure below. Okay, here there is a certain figure. Which is a combination of triangles. Okay, say A, B, C, and there is another segment. Okay, say this is DE. Okay, and this figure, BC and DE are parallel. Okay, students, here this symbol is a symbol that or most mathematicians use to represent parallel lines, right? So in this figure, what is given, the side DE is parallel to BC, right? Okay, so based on this, prove that triangle ABC is similar to triangle ADE. Okay, here in this figure, you can see two triangles. One is the bigger one, ABC. The second one is ADE, right? So the only thing that we know is BC is parallel to DE. Having this information, we are asked to prove that the bigger triangle is similar to the smaller one, right? So here we apply our previous knowledge to prove this fact. Okay, before I proceed to the formal proving, I want to remind you some of the concepts of parallel lines and transversal, right? From your previous grade level, you have the knowledge of parallel lines and transversal line. If these two are parallel lines, a line cutting these two is called transversal line, right? So in this figure, this angle and this angle are congruent, okay? alternate interior angles are congruent. And this one, and this one are also congruent. These are called alternate interior angles. The other thing, if you have two intersecting lines like this, these are called vertically opposite angles, right? So vertically opposite angles are congruent. There are alternate interior concepts here that we are going to apply to prove this fact. Okay, so now consider triangle. Consider triangle ABC and triangle ADE. Clearly, angle A is common, right? So one of the things that we can see is angle A is congruent to angle A. Okay, we do have two congruent angles. This angle A is common for both. Okay, this is common angle. So this is one of the things that we observe from the picture or from the figure. Okay, we have this thing. The other thing, BC and DE are parallel. So this line can be considered as a transversal line. You can consider AB as a transversal line, or you can also consider AC as a transversal line for the two parallel lines. So if that is the case, this angle D and angle B are the same, right? By alternate interior angles. So angle B and angle D are the same, or they are congruent by alternate interior angles. Okay, alternate interior angles, right? So now we do have two corresponding congruent angles. Okay, one is the common angle A, which is the same for triangle ABC and triangle ADE, right? The other one is we can observe that angle B and angle D are congruent by alternate interior angles. Now, remember what theorem 4.1 was saying, okay? In theorem 4.1, or angle-angle similarity theorem, we only need two corresponding congruent angles, right? So since we have now two corresponding congruent angles, by default, their third angle will also be congruent, but we don't need to show that, right? So we can say that, therefore, we can say that triangle ABC is similar to triangle ADE, okay? This happens by angle-angle similarity theorem, okay? By angle-angle similarity theorem, okay? This is one fact that we can prove regarding the similarity of these kind of figures, right? Now let's see another proving that requires the concept of angle-angle similarity theorem, right? All right. Given the figure below, okay, here we have a certain figure with characteristics of, say, like this, and let us denote this AB, CD, and this point is O. Here in this figure, assume AB is parallel to CD. Okay, this figure is different from the figure that we have seen before. So in this figure, what is given? This side AB is parallel to CD. Okay, we have this thing. Then prove that triangle ABO is similar to ABO is similar to triangle CDO. Okay, so to prove this, again, we will apply the concept of parallel lines and transversal, right? So if these two lines are parallel, and consider AD as a transversal, okay? If AD is a transversal for the two parallel lines, clearly this angle and this angle will be the same, okay? So let us formally write the proving, okay? So angle A and angle D are congruent by alternate interior angles, by alternate interior angles. Okay, so these two are congruent. Again, consider BC as a transversal for the two parallel lines. If BC is a transversal line, clearly this angle and this angle are congruent, right? So angle B is congruent to angle C, right? By the same reasoning, okay? By alternate interior angles. We don't need the third case, but if you take these two angles are also congruent. By default, as I have told you earlier, if two of the angles are congruent, then the third angle will also be congruent. So these two angles are congruent vertically, opposite angles are congruent. That is always true. So we have these two facts, therefore triangle ABO is similar to we started from here and here, so DCO, okay? Triangle DCO. You need to move the way this is going, right? So this is a proved fact by the first theorem, by angle similarity theorem, right? This is how we prove, okay? So this kind of proving requires the first theorem, which is about angle similarity theorem. So this is all about the proof of some triangles. Now let's see some examples regarding similarity of triangles that requires the concept of AA, or angle similarity. Okay. Given BC is parallel to DE, as shown below. Here, there is a figure with sides. Say this is A, this is B, this is C, D, E. Okay. So in this figure, it's given that BC is parallel to DE. Okay, these two sides are parallel. And assume the length of AD is X and DB is 3. And assume this length is A up to A is 5 and E up to C is 4. Okay, so find the value of X. Find the value of X here. Okay. If you remember, in our previous example, we have proved a certain fact regarding a similarity of triangles having this form. Okay. In our previous example, we have proved that if these two sides are parallel, the two triangles, triangle ABC is similar to ABC is similar to ADE, triangle ADE. Okay, we were able to prove this fact using angle-angle similarity, right? So if we know these two triangles are similar, we can easily find the value of x, right? So let's do it. Okay, triangle ABC is similar to triangle ADE this implies the ratio of the corresponding sides are the same. So let's take it everything properly. AB over AD is the same as BC over DE. This is the same as AC over AE. AC over AE. Okay? The first step is very important to determine the remaining thing. Okay? If you do a mistake on the first step, your answer will be wrong, right? So now let us put all the information that we have in this picture and obtain the required things, right? So AB is the distance between these 2 points. That means AD plus DB. So you need to add these 2 things. So AB is x plus 3 over AD means x, right? This must be the same as BC over DE. Here, BC and DE are not known, so we don't have values here, so we can jump it, right? Because we have another important information about these 2 triangles on the third proportion. That means the third proportion is AC. AC means the distance from here up to here. That means totally it's 5 plus 4, it's 9. Over AE means this distance, so you can take 5. Now we have equations, so you can use simple crisscross to find the value of x. So let us crisscross it. This implies 5 times x plus 3 is equal to 9 times x. Okay, multiply this by this and x by 9. The next step that you need to do is you have to distribute the number outside the bracket into here. So it becomes 5 times x plus 5 times 3 is 15. This must be the same as 9x, right? So collecting like terms, now we need to collect like terms. So take this 5x to the right side. Then on the left, you will have 15 is equal to 9x minus 5x. So 9x minus 5x means 4x, okay? The last step is dividing both sides by 4. Then dividing both sides by 4 gives us x is equals to 15 over 4. Okay, this is the value of x that makes these 2 triangles are similar. Okay, if you change this x value, if you take any x value other than 15 over 4, you can check that the 2 triangles cannot be similar. That means DE and BC can also, they cannot also be parallel, right? I will give you this thing for you to check by taking x is equals to some number 2, okay? Put x is equals to 2 here in place of AD and check whether all these proportions are the same or not. Definitely you will get different proportions. That means the 2 triangles are not similar. So the only x value that can make these 2 triangles is similar is x is equals to 15 over 4, okay? So let's see another example regarding the first theorem. in the figure below, say the figure is like this. Say this is A, B, O, C, D. Assume AB is parallel to CD. Okay, so in this figure, it's given that AB is parallel to CD. Okay, you can call it CD or DC. It talks about the same line segment. If this is given, the other thing, if the length of AB is 12 and this side is 15, say this is X, this is Y, say this is 5 and this is 7. Okay, so from this figure, find the value of X and Y. Okay, so here we have a certain figure in this form where AB is parallel to CD. And in our previous example, we have seen a certain fact, and we have proved that triangle ABO and CDO are similar. Okay, we have seen that proving. So we know some properties of triangle ABO and CDO, right? So having that information in your mind, find the value of X and Y here. Okay, so using the fact that we derived in our previous example, clearly triangle ABO is similar to triangle CDO. Okay, these two triangles are similar by angle similarity. Already we have proved this thing. So here we are asked to find the unknown values of X and Y. Okay, what must be X and Y so that these two triangles are similar? So we do this in this way. Okay, triangle ABO is similar to triangle CDO by angle similarity. Okay, these two triangles are similar, right? So if these two triangles are similar, the next step that should come to your mind is the ratio of the corresponding angles must be congruent, right? So that is the immediate step that should come after this. So AB over CD must be the same as BO over DO, and this must be the same as AO over CO. Okay, so this implies AB is 12. Substitute all these values, and CD is 15. This must be the same as BO. Okay, BO is 5 over DO or OD is 1, right? And this must be the same as AO, which is AO is X, over CO is 7, right? 7. Now, taking the first two proportions, we can get the value of Y. Take these two, that means 12, okay, you can use crisscross. 12 times Y is equal to 15 times 5, okay? So this means 12Y is equal to, what is the product of 15 and 5? Well, 15 times 5 is 75, right? 75. So now you can easily get the value of Y here by dividing both sides by 12. So Y becomes 75 over 12. Or you can write the simplified form of 75 over 12. By 3, it's 25. By 3, it's 4. So the value of y in this figure must be 25 over 4. Similarly, we can take these two proportions. Okay, that means 12 over 15 is equal to x over 7. Now you can crisscross it. Then it becomes 12 times 7 is equal to 15x. Okay, students, I need you to check the product of 12 and 7. I guess 12 times 7 is 84. You can make a correction if it's wrong, but 12 times 7 is 84. 84 is equals to 15x. So dividing both sides by 15, the x value becomes 84 over 15. Okay, these two are the required values. Okay, so in our case, x is 84 over 15, and y is 25 over 4. Okay, these two are the required values of the unknown variables. Okay, this is all about today's lesson. So far, we have seen how we can check whether two triangles are similar or not by applying angle-angle similarities, and we have proved a certain facts regarding triangles, and we were also able to find some unknown sides of a certain similar triangles. So this is all about today's lesson. I hope you enjoyed the lesson. Thank you for listening.